From this figure, we can easily see how our defense mechanism works against different attacks. You can notice the difference. Without any difference, we can get 95% accuracy, whereas in our defense, we reach almost 100% accuracy. This shows how we can effectively defend our defense system. So this is also another example. We can see the almost 100% accuracy for all the defense mechanism. Without defense, we can able to get only 95%. Hi guys, today I will show you how to design a federated learning system to mitigate the different attacks. So for that, we have taken a two-class problem from a planned data. So for that, we have taken a data set. This is the class 0 and this is the class 1. So these are the two planned data. We are going to classify the classification of these plans. Also, we will apply some of the attack and we will check the system how it's working for the different defenses or how to mitigate those things. The custom data set we have used. We can load our data and corresponding the labels here. After that, once we loaded the data set, we can go to design the simple network. So this is the simple CNN network that we used for train the clients. And after that, we need to do the FL client. So here only we are doing loading our data and we are loading our simple CNN model, then backpropagation. So everything we are doing here. This is the training for that federated learning. So then we are defining the training function. Here we can give the global model and each epoch it is going to then in each epoch it's checking it doing the training and backpropagating, and we are getting the accuracy and loss value for all the clients separately here. So once the client training is completed, we are going to apply our attack. So there are two attacks, data poisoning attack and model poisoning. So these two attacks we are going to apply here, and we are using four defense mechanisms how to mitigate these attacks. So this is the definition for the data poisoning attack, and this is the model poisoning. So data poisoning and model poisoning is nothing but data poisoning will add significant of noise to the model parameter, and the model poisoning attack means reverse the update direction with amplification. That means we will apply some of the integer values to reduce those amplifications. So these are the two attacks we used here, and this is the FL server, Federated Learning Server. During the time of aggregation, we will be using this one. And here you can see the aggregated after. So these are the four techniques we are used for mitigate those two attacks: model poisoning and as well as the data poisoning. So krum and trimmed mean and norm clipping and loss base. So these are the four mitigation techniques or four defenses we are using to reduce those attacks. Then this is the fed average aggregation function. Here we can use those aggregation based upon these different techniques. Then separately we are defining the krum aggregation, how we are implementing those things based upon the distance vector and the similarity one. And the next defense is trim mean aggregation. So trim mean aggregation is nothing but trimming for not enough clients for trimming. We will remove extreme update before averaging. That is the trimmed mean aggregation. In general fed average, we'll aggregate all those things. In trimmed means, so we will remove the extreme updates before aggregation. And the third one is the clipping. So clipping also, so we will clip the norm over updated those values. Also we are removing those values, clipping those values here based upon the particular threshold. If it is greater than threshold, we'll remove those values. So that's one of the defense also. Then loss based aggregation. So loss based aggregation also same only. The loss value is greater than the particular threshold, we'll remove that one. Otherwise, we'll filter out that one. After that, the evaluation metrics we can define here, how we are testing with our data with these attacks as well as the defenses. So these are the things. Finally, we just apply all those things, defense mechanism as well as, and we will check it how it's working for each round. So each round we will plot those things, how it's working for different attacks and mitigations. So this is the plotting area, how we can able to plot that one. Then finally we can give our data set here and a number of clients, number of malicious also, and a number of rounds. So this is the code. So once we completed, when we run this code, we will get this kind of result. Like first, so here we can see the created three clients. We have given three clients, so it is creating those data. Then testing defense, no defense. We are not using any defense. Directly we are applying some malicious clients, and we are checking how the performance for each round. After that, secondly we applied the first defense mechanism krum, how much is the accuracy and the trimmed mean, and how much is the accuracy and the normal clipping, how much is accuracy. Finally the loss based. So finally we will get a graphical data like this. Here you can see the malicious the communication round, and we can see the accuracy for each communication round for each defense mechanism. So here you can see no defense krum and trimmed mean and normal clipping and loss based. So this is the loss value for the corresponding defense mechanism. So third one is the communication round mask and the number of client participated, how many malicious client is participated in the particular round, like that. So the final one is the defense mechanism. This is the final accuracy. So if you see this one, if there is no defense means we will get the 90% accuracy. If there is a defense means we will get 95% accuracy. But krum only doing good compared to the other three models, trimmed mean and norm flipping and loss based defenses. Here you can see this is without any defense, so 90 percentage. With the defense we will get 95 percentage. So other three methods failed to mitigate those attacks, but krum is performed well here. In another case, if this is only for, I have given only low number of epochs. So another program also I have run it for high number of epochs. There you can see the performance in different manner. So here you can see that one. If you see these figures here, the krum as well as the trimmed mean giving 100% accuracy. Other two are getting 85 and 75. So mostly these two techniques performing well regarding these kind of attacks, and compared to other two things, loss as well as the clipping one. So this is the same graph only, but you can see the difference, the accuracy difference for this one and this one. So first one is we have used less number of epochs. Second one is we have applied more number of epochs. That's why we are getting good result compared to the original. So if we are applying any attacks like model poisoning and data poisoning, these two krum and the trimmed mean is working well compared to other two, normal clipping and loss based system. So if the attack is coming, even during the time of aggregation, it is exactly aggregating the real updates and removing that attacked values, and we are able to get the good accuracy in the server side. So that will ensure that our system is more perfect. Even any attack is coming to during the time of sending the data from the client to the server or server to the client. So this is the full program for how to design the federated learning system with some attacks and how to mitigate those things. So I hope you understand that. Likewise, you can apply for your system for the different attacks and different mitigation techniques or different techniques, and you can see the result performance, how is varying from one and another. So thank you. Thanks for watching. If any doubts, you can ask me and you can contact me. Thank you. Thank you for watching.